Hello, everyone. Hi, Julia. Hi, Justin. Harry. Amr. Hello, everybody. Any news on your front? Hi, Denise. Thank you for doing the experiment. It was interesting. My colleagues were very excited to hear your impressions. Anytime. Good, good. All right. Let's start. All right. So today is our last session on Lab 3. That is, we won't have any more Thursdays for you to work on Lab 3 report. So I hope that if you have any questions, you will get a chance to ask these questions. Yes, Leroy, the answer to your question is yes. Until the end of this week, you can do it. Okay. So that's what we will do today. We will talk about a little bit the research article that goes into the second paragraph of your introduction. Then I want to spend a few moments showing you how to do the right figure in Excel. And then we'll talk about the narrative that goes into the two paragraphs of the results. Hopefully there will be time left for you guys to, hi Nisrian, to do some group work with your partner on Lab 3. And I would like to see first the figure and the results. Obviously, I also asked you to look at the scores for Lab 2 to see what is it that you are not still doing right, so you can fix that for Lab 3. Again, hopefully we'll get to that in the second half of today's class. First thing is, oh yes, just to remind you that all your group work for Lab 3 should be done in your group Google Doc. Google Docs keep the history of your work on the document, so we will be able to easily see your contribution. What I will do next, is it going to be next week or the week after? Excuse me. I'll show you the form that I will ask you to fill out at the end that will help me decide your contribution. So one thing you could do is you could say the two of us worked equally on all 3 lab reports, then your grade will be the same. Now, if there was a well-defined leader, the person who organized the two of you, who did all the logistics and submitted and read the final report and edited for consistency and then submitted, this person is the group leader. And according to the syllabus, the group leader will be upgraded half a letter point at the end, regardless of anything else. And potentially, hopefully not in this class, if there is somebody who was a real slacker, then that person's grade will go down half a letter grade. So I'll show you the form and I'll post it on the Blackboard so you can start filling it if you want. But the most important thing is to have that history in your Google Doc, because then there is no ambiguity in how you guys worked together as a group. So once your lab report is done, that is, everything else is finished, you should download it in either Word for Windows or something else, and then convert it into PDF if you want, and submit 2 weeks from today. That's going to be December 3rd. It's going to be the last class of that week, and then there will be one more on December 8th. We'll finish chapter 12 and maybe talk about life. And if you guys have any questions, logistical questions, advisement questions, life questions, and why are we on this earth? That's a good one. Okay, this is the schedule, what's left. Obviously, we have already had our class in the beginning of the week. Yes. Do you guys know the answer to this question? Nearing the end, yeah. So as you can see on this table, yeah, this is today. We only will have Tuesday class on, well, next week, because Thursday's our Thanksgiving. We'll do problem solving. Obviously, your quiz 11 is due. Some people have already started doing that. Again, I remind you to try to do your quiz a bit earlier, before it is due. So if there are any issues with Blackboard or your internet connection, I can fix it. 2 classes, first week of December. That's when your lab 3 report is due, like I said. Report is due on the 3rd. Right. Okay. And December 8th will be sort of the conclusions to the class, finishing whatever is unfinished. Remember, there are no final exams. Everything is already in Blackboard. In terms of your blogs, I will ask everybody to do that just to make sure that I haven't missed anything. So what I need you to do is to create a table or something like that, where you would list all your postings in 2 categories. One category where you get just 1 point. So that's lecture summaries and activities of various sorts. And category 2 is your work on cognitive articles. It's a separate category for which you get 2 points. Now, remember, in the beginning, I was grading. I don't need quizzes, Justin. I have them in Blackboard. So I need to make sure that I have credited all your blog entries. And there it might be, a little tricky, because the way you guys sometimes posted was after the week that they were supposed to be posted. So I could have put my numbers in a slightly different place. So I want to make sure that you get the credit that's due. So like I said in the beginning, I sometimes did not give you a full credit if I saw a lot of errors. I stopped doing that in the middle, knowing that I was excited to see you do work. Not necessarily always correct, but that comes as you practice, so that I can double check your points and adjust them if necessary in my Excel sheet, which I will then obviously align with blog points. Remember, there's 50 of them on Blackboard. And at this point, if you want, you can now take the running score, the column called total in Blackboard. It gives you your current scores for everything. So just to remind you that we haven't done anything with lab 3 yet, so these 50 points are not there, but you have 10 quizzes. That's maximum 100 points. You have 2 lab reports, maximum also 100 points. And you have, well, at least 10 weeks for, maybe not 10, maybe 9. Well, let's make it 9. Say 9 weeks of participation points. So maximum would be 36. So now at this point, as of today, if you have already taken quiz 1, don't count it. So you can take this number, 236, and this is an equivalent of 100. Okay, so anything between 92 to 100 is an A. All right, so you can calculate approximately where you stand, which will give you more incentives to do better on the remaining 2 quizzes. Remember, 2 lowest scores will be dropped, but I can't do that until the last quiz is finished, which is 2 weeks from now. And you can still get a bunch of participation points. Like I said, I'm not closing them. That is, you can go back a couple of weeks. I don't think I'm going to go to the earlier ones and reopen them because that makes no sense. And try to get as many points as you can. Right. So that's that. And once on the 8th, so you'll submit lab report 3. We can go back, but not too far. Yeah, Brandon, maybe 2 or 3 weeks, because it makes no point of going back to chapter 1. That was long ago. And one of the reasons was precisely trying to avoid this kind of cramming at the last moment. The idea is that I would like you to work throughout the course. That's why there are no midterms or finals, because I don't believe in cramming. I don't think it contributes to any kind of knowledge. But doing something, I don't know, maybe we can spend another minute. Maybe somebody could reflect on the activities. Did you guys find them useful? Did they contribute to your knowledge of cognitive psychology? Of course, they are a little bit of a burden now. That's how online classes are run. But I'm just curious because I will be teaching 2 sections of 288 in the spring again. So I want to make it a little bit better. If anybody who wants to unmute himself or herself and talk to us for a minute. Oh, okay, good, Rebecca. I'm happy to hear that. One of the ideas was to give you a choice so that you could select something that interests you more than others. Now, the question is, and it's not just a question to Rebecca, but to everybody else, how onerous was it? I mean, was it taking a lot of your time in addition to, Justin likes it too. Okay, good. Anybody else? I'm very curious to hear from you because the activity component was different from my face-to-face format of that class. Here you were working on your own, looking for things, as opposed to me directing your activities. Okay, Denise liked it too. Leroy, what's your opinion on the activities? Oh, good. Good. Okay. Yeah. Yeah, I need to figure out how to make it even more precise. Just saying it's a summary doesn't always work for everybody. I have low points because I never had time to balance work and my other classes, but that's more of a personal problem. Yeah, I know you guys taking sometimes 3 or 4 classes and now in the online format. But I think that's what you perhaps could take out of this semester, because as you know, we will continue with this format in the spring. And there is no guarantee that CUNY will go back to face-to-face even in the fall. I'm not saying that this is their position. It's just rumors that are floating. Super hard to balance them all. Same here, but it's definitely my fault and not the blogs. Great. And look, you are also a special bunch because you are people at the Verrazano level or similar to Verrazano honors students. So you have to, in the past when we were doing face-to-face classes, you could come to class and do whatever you had to do and thinking you will catch up in class. But now only catch up that you have to do is on you, which means you need to rearrange your time in such a way that you can contribute equally enough of individual work to every class. All right, if anybody has any other suggestions for me, I will be very happy to see and hear them. The thing is that I do it when I have the time because of other classes. I know everyone else got other classes too. It's always good to have extra points from the blog. I do it when I have a chance. I'll try to do more. Good, Justin. That's what I would like you to do in the remaining 3 weeks. Do as much as you can. Good. So again, like I said, any other ideas, please email me or talk to me. I will be very glad to hear your suggestions how to make the experience a bit better, because my 2 new sections of 288 in the spring are not Verrazano. They're going to be regular, which is 45 students per class. So 90 new warm bodies to torture. Just kidding. But I don't want to torture them. I want to give them a chance to learn.
Professor?
Yes, go ahead.
So what I feel like with the blogs, like maybe
Mm-hmm.
you could up doing 4 a week, because you're not gonna know if you're gonna have like 2 tests 1 week, or if how your other classes are gonna be. So maybe like in the future they're gonna be so crammed that they're not even gonna be able to like look at it. So maybe if they're allowed to do a little more per week, they'll feel more better about, like, comfortable with
So
their grades.
you're saying more than 4, like
Yeah, like maybe
6
like
or
5 or
8,
6, something like that.
or 5 or 6? I
Yeah,
see.
just so they
I
have
will
more time,
to
maybe.
to accumulate more points. Yeah.
Yeah.
Okay. Great. Great. That's a good suggestion. I mean, I already have 6 to 8 activities posted anyway.
Yeah.
Uh, Karen, the one set of entries that I haven't graded yet are the ones that are for this week for concepts and knowledge, because they're open until Monday, until the 23rd. Everything else is graded. That's why I'm saying again, and I will probably email you guys or post it on Blackboard, that I need you to go back to your blog entries and give me the, the points in 2 categories. One category, 1 point activities. Let's say you've done 27 of them or something. And then another category, whether you have answered the questions based on the cognitive psychology articles. These are worth 2 points. Again, just to remind you that in the beginning I was grading them seriously. Sorry. And therefore, sometimes if you did not do the variables correctly, I would only give you a point. So, okay, about 5 that may have not been graded for me. Yes. Well, Karen, it's actually up to you to double check everything before this week to make sure that everything you have done uh, is accounted for. That is, my number of points on Blackboard coincides with your number of points. Okay, so if there's something that's missing, then I will need to double check and add that.
And
So I
when do
would,
you want
uh,
this?
go
Sorry.
ahead, Nick.
When do you want this by? Like, do you want us to just send an email, like charge, just saying 1 point, whatever, 27 blogs, or 2 points, 4 articles?
Yeah, yeah, it would be better for me if you were to do it by December 3rd, because that's when basically all the activities are done, and that will help me to make sure. Obviously, I will be grading 2 more weeks, right? This week that will end on Monday, the 23rd, and the week that will end on November 30th. So these will be new ones. But for these, I'm not going to be giving you half points. I will be giving you points just for doing that. So all I'm interested in is, Nick, wait, can you repeat what you want us to write? The chart you were saying to do us. Double check. Right. Okay. So you're going to go to your individual blog and you could create a little table. That will probably be the easiest for me. Excel or just plain table. We'll say, uh, week one, September 3rd, uh, 3 1 point entries, 1 2 point entries. So you will have like 4 columns, and then do it all the way to this. This is week 12. So from week one, which I don't think had any, so week 2 through week 11, that's what I need. I need this little table telling me how many 1 point entries you have and how many 2 point entries you have. Okay?
Okay.
Which
So
means I will, go ahead.
if we go, let's just say we go back and we do like a couple just to like get the number up.
Mhm.
Would we have to email you saying we did it, or will you show? Will it see like
What
they went back
the
to week
black
9 and did
the
something?
blackboard will show me anything that is ungraded, that is anything that I haven't looked at. So I will see that in Blackboard. You just have
Oh,
to
okay.
continue to monitor the points, okay?
Okay.
So if you submitted a new blog and I did not grade it by December 3rd, then you should alert me and saying, "Hey, look, you missed that one." So I'll
Okay.
I'll go back. And I like the way the blogs are sort of counted in one column up to 50 points. On the other hand, you don't see the breakdown by weeks. And like I said, some of your activities were, you posted them not on the week they were due, but later, which also is okay, except it messes up my counting. That's why I'm asking you to do it yourselves. I don't have any problems giving you points if I miss them. So again, remember, my job is not to make your life more difficult or fail you or anything like that. If
Okay.
that was our job, we would not be teaching. That's okay. Good. All right, let's move on. Perfect. So close this. Today is another chance for you to get 1 point, um, because you will be able. Okay, good, Karen. Yes, you can do that. So you'll say week 12. That's fine, and I'll go and make sure. For people the who were interested in doing the experiment with my colleagues from Canada, I have already graded their week 12 blog entries. So that was Denise and Brandon. Leroy will do that a little later. So Leroy, I will add these points to week 12 points. And I'll obviously let you know, because you'll have to send me the code that you will receive at the end. All right. So if I know Karen is one of these people who is interested in applying to a master's program. Anybody else who's thinking of a master's program in the future? Julia, okay, good. Denise, perfect. Raphael, Leroy, fantastic. Oh, a bunch of you. Amanda, good. So Jeffrey, if you have time, please attend this event today at 2:30 on Zoom, of course. You will have 3 of my younger colleagues, Dr. Denton, who does counseling, social stuff, Nisrian, good. Dr. Wagner, who does infant cognitive development, how babies learn to read emotions, very exciting stuff. And Dr. Yetnikov, whom uh, will it be recorded? I think, hmm, we'll have to ask Valky, Dr. Duran Naruki, who runs this thing. But those of you guys who will be there, please suggest to the organizers that they should record it. I think they probably will, because it's the general stuff that many people are interested in. And the last person is Dr. Yetnikov, who is, if you haven't taken statistics yet, she is the person to take statistics with. I think, in my opinion, she is the best faculty we have for statistics. We have a few other people who are pretty good, but I think Leora is the best. So if you're still thinking of 266, consider taking it with Dr. Yetnikov. And Amr, how is it going? She's really good. Yay. Excellent. Yes, it's going to be yet another difficult class. I'm sorry. But it is fundamental. Explains a lot of stuff. Very good. Very good. I observed her class and stats was hard. Yes, but Amanda, you know it. Look, whenever I had a question about statistics, you were able to answer it. So it was not lost on you. Fantastic. Money well spent. Good. And she makes time for you. Good. Yes, B minus is it's a passable grade. It's not a C, right? Okay, good. So do that, and perhaps if it is recorded, listen to it. Now, again, you can still write a summary even if you do not attend it in person, and that's fine with me. Goody. So going back to Lab 3 report, let's spend just a few minutes on Meyer and Schraneveld's article. I asked you to focus only on experiment 1 and general discussion because experiment 2 is irrelevant to our Lab 3. Your Excel file with data is already posted. We'll get to that because I want to work with you on your figure. I'll show you again how to do descriptive analysis. I would like you to consider learning, well, not learning, but using JASP, free statistical software, which is very user-friendly. It's not like SPSS. If anybody is familiar with SPSS, it's a horrible, horrible program. But you can do it in Excel as well, which is not that difficult. And then I would like to spend a few more minutes talking to you about your bar graph, because there is still some issues in terms of understanding what this bar graph should look like. Statistical analysis using a paired samples t-test, exactly the same one we had for the previous 2 labs. I'm not doing anything new. Please continue to write your draft in Google Docs. You will use experiment 1 from Meyer and Schraneveld's article in the second paragraph of the introduction. Make sure you have all your 8 components. And there is one little thing that I added. I would like you to run your text when it's completed through the rubric, the one that I sent you for Lab 2. But now you will be grading yourselves. So when I get your Lab 3 report, I will look at the text and the rubric. Now, one of the perhaps little issues that you need to think about, that sometimes it's not just students, it's everybody. We think we know more than we do, and we can see that. But in fact, that's not necessarily the case. So I've had some examples on the past where the entire rubric will be check, 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 check. It's a perfect lab report, but it's not. So make sure, think of this lab report as if you are grading somebody else. You don't want to be harsh, but you want to be fair. You want to make sure that that person, it's not you, somebody else, gets the point, because this point is well deserved. The stuff is there. Again, if you have some questions, certainly could ask me by email or on Tuesday before Thanksgiving. So you will submit these 2 things together. It may be easier for you to attach the rubric to the lab report itself or submit it separately. You'll see whichever way it will work for you. But basically, I'm asking you to grade yourselves. And all I have to do is to compare your grades, what I think when I read your lab report. Okay, so if let me stop sharing for a second. And if we go to Blackboard, let's do that. Blackboard. Again, it's a little small, but here is our experiment 3. These are the same points that I just made in the PowerPoint, except for this yellow stuff. Everything else is the same that was for lab 2. So now if you click on experiment 3 on Blackboard, you will get the components. So here is the class Excel data that we'll look at soon. This is Maya and Schwaneveld's article that I posted. Yes, yes, you grade it together, Brandon, and send it to me. Yep. And I'm asking you only to focus on this one manipulation, related, unrelated words. Here is the rubric. It's the same one that's posted at FF. Okay, it's called new because remember I changed it slightly between 1 and 2 to align it better with what you write. And the last link is the link for submission. I did not put the word submission in it because it goes into Blackboard and becomes a very wide column, difficult for me to see. So this, and that's the only place where it's posted. So there is no ambiguity. Okay, so you'll have to download your data and use it for descriptive and inferential statistics. Close that. Okay, let's spend just a few minutes talking about, oh, where are we? Here we go. Talking about the article. All right, so that was the last bit of our lecture on Tuesday that had to do with an alternative way to represent categories. Now, in this case, our categories will be special. They will be words. They will be items in our mental lexicon. A mental lexicon is a vocabulary of the language that we speak that is sort of hosted by our mind somewhere. And there are interesting ways of thinking about how mental lexicon is represented in the brain, but we're not going to be talking about that. So this comes as an alternative to Aristotelian view of categorization as definitions. So if you take a word like, oh, be a good example. Let's take a word bachelor, not a bachelor's degree, but a bachelor, and in a normal, typical language. Who can give me one of the meanings of, or a definition of the word bachelor? Just type it in the chat. Who is a bachelor? Someone who is single. Okay. If my friend Jane is single, is she a bachelor? A single man. Okay. A single man. All right. I have a friend who is a Catholic priest. Is he a bachelor? Not married. Okay. Well, a Catholic priest is a man and he is single. Why isn't he a bachelor? A single man looking for companionship. Okay. I have a 14-year-old son. He's a man and he's singular. Is he a bachelor? Okay. You can see that there are many nuances to the meanings of the words. So in Collins and Quillian's approach, they did it for religious reasons, and your son is too young. Okay, so perhaps do we need to include all of these additional restrictions into our definition of a bachelor? Because calling a 14-year-old boy a bachelor is wrong, perhaps. So in the Collins and Quillian's approach, they say we represent the words as nodes. So here it says node is equivalent to category or concept. So think of them as words because that's what we are working with today. And these words, these nodes, are linked. They're linked with lines. And that, according to this very early work, is representative of how we connect the words in our mental lexicon, quote unquote, aka vocabulary. So this is how they represented it in the paper in 1969. For those of you who were not in class, we discussed the three, what's called a hierarchical vertical organization of concepts, or nodes in this case. So this green level is what we call basic. That's the most important level in categorization. That's the entry level for everything. We think in terms of basic categories. And if we go, so tree, flower, bird, fish, these are all basic categories. If we go up vertically, right, we're going to go to what's known as superordinate categories. And these are plants and animals. And we can even go up one level more and talk about living things, right? So superordinate above basic, or we can go down and we're going to get subordinate categories. And the way we think of them is by taking the basic level and losing some features. So the higher you go, the fewer features you will have that characterize this level. Or you can add categories when you go down. So a pine is a type of tree that is evergreen, has needles, blah, blah, blah. It's not true of all trees at the basic level. That's why you will be going up, you will be losing those features. Okay, so here is the idea, right? You have the nodes, and then you have lines that connect them and give us characteristics. So here is a feature of having something. So a tree has bark, right? A tree is big. A tree has branches. And this relationship is a pine is a tree. All right, so the lines represent the connections, and the nodes represent hierarchical organization of these categories or words in our case. And that's known as semantic network because it's nodes and lines that connect, right, a bunch of words into a. And of course, this is a simplification. If you start thinking about more complex categories, you'll start scratching your head, not sure how to do that. So that's why we're looking at simple examples. And the way they would justify this is by, remember, we always have experimental evidence. How do we know that categories are organized hierarchically with the basic level, superordinate, and subordinate? Well, they say we can ask people to do a very simple task. And this task is sentence verification. So imagine that you're hearing a sentence like, a canary is a bird. And if you think that the sentence is true, you're going to hit yes button. If you think the sentence is false, you're going to hit a no button. And versus, so this is sentence one versus sentence two, a canary is an animal. That's a little funny, right? But if you look at the semantic network, animal, living thing is up there, right? So here's the idea, they say. If all you have to do is just move one step to verify the sentence, your reaction time is going to be fast because you're only doing one step. In this sentence, you have to go up two levels, right? So your reaction time technically could have be, twice as long here as it is here. All right. Well, twice as long is an exaggeration, but certainly this reaction time is slower than this. And that's what they found. And that was one of the justification for this Collins and Quillian's model. Okay. A continuation of this. So this model, when it was proposed, was an alternative for categorization. So it was pushed forward by other people. Here is somebody that you already know, Elizabeth Loftus. We talked about her when we were in chapter 7, memory errors. She was one of the people who created and used the concept of misinformation effect, post-event misinformation, PMI, together with the same chap, Collins, that was of Collins and Quillian. They expanded this idea and they said, look, what happens at the nodes, in this case words, when you hear the word oak, it gets activated. Think about neuronal uh, connections and firing when we talked about the biological basis of cognition in chapter 2. So what happens to that node in our mind, it becomes active. So imagine that it jumps a little bit up and down. It says, well, I'm activated. You talked about oaks. I'm an oak. All right. And then they say, well, once you activate the oak node, whatever it is connected to will also be activated. It's just like the neuronal firing, right? But the in sort of in contrast to neurons who either fire or don't, here the activation will actually be different in magnitude. So if you have a close node like oak to tree, the tree will be activated almost as much as oak. But anything above that, what was that? Plants, something like that. The activation will continue up the hierarchy, but it's going to be tempered. It's not going to be as powerful as the other two levels. So they say the activation spreads throughout the network because all the nodes in that network are connected. So all of them will get some activation, but this activation's level will be diminished as you move through the semantic network. So now they say, if that is the case, we can use yet another well-established method in cognitive psychology. We can prime words. So if I say tree, you should start thinking about oaks and birches and aspens and whatever else is in the tree family. So if you, a few seconds later, are presented with the word oak, you will be ready to recognize it. That means your reaction time will be a little bit faster because you just heard tree a few seconds ago. And that's what priming is all about. And get rid of this. That is the crucial concept underneath the lexical decision task. And that's what your experiment 3 is about. It is about lexical decision task. Believe it or not, until 1971, there was no lexical decision task in our arsenal of methods. And I was very happy to hear from Denise when she did this experiment from Canada that she said, oh, look, and we did the same task as in lab 3. And she recognized it. I was very happy about that because it's one of the probably most widely used tasks in cognitive psychology. So what happens here is a participant is presented with a string of letters. It's always about written language. I mean, there are some variations, but we're talking about the classical version. And all you have to do, you have to say whether the string of letters is the word of English. In our case, because we're doing English, obviously, if you're doing it in Spanish, it's going to be Spanish or whatever. So, and all you have to do is click yes button if it's a word of English, or no button if it's not a word of English. Now, of course, if somebody gives you a string of letters that looks completely weird, nothing possible in English, so I don't know, something like clip Yeah, you don't even need to process this whole thing because you know that TL at the beginning of the word is not allowed in English. So you will be very fast in saying no. So these non-words that I used in lexical decision tasks, they almost always look like they are words of English. I can give you an example actually from the lexical decision task in Cog Lab that we used to have for Sci 330, which is experimental psychology, cognition, and perception. For the lexical decision task, there was a practice set. And this practice set, students were supposed to achieve 80% accuracy to pass on to the main experiment. And that particular class, I would get students coming out of the booth because it was face to face, and they would say, I can't get through the practice items. I can't achieve 80% accuracy. And I was like, why? So it turns out I'm simplifying, but there was one particular item that I don't think anybody knew. Let's see if you guys know it. Okay, so perform a lexical decision task on this string. Is it a word of English or non-word? What do you think? Oh, good. Uh-huh. Okay. Who knows what it means? Yes, it is a word of English. Yeah, you're right. Similar to fame recognition, yes, but it has a nuance. Can somebody give me an example where the cloud would be uh, naturally used? Okay, good. Yes, celebrities have a lot of clout. It means that they are influenced, yeah, that they may not necessarily actually have what it takes to be famous, but they use it in such a way that they become famous. So it's a there is a little bit of semantics to that, but in this particular class, nobody knew the word cloud. And the way Coglab was designed, they would give you the same non-words over and over again. So if you can't, you always say it's a non-word, you're not getting through. Okay, good. So that's the lexical decision task. And that's exactly what you did in lab 3, because I obviously programmed that experiment for you to match Meyer and Schranevels. So in Meyer and Schranevels, right, let's look at the article quickly. Close this. Oh, stop sharing. Come on. Now let's share. Okay, it's a little small, right? But let me make it a bit bigger for you. All right, so here is our, obviously there is the previous page, which is the introduction, where you should be able to recognize some important words. Also, just a little suggestion for you. One of the things that all of you have been struggling with is the abstract. The best way to learn to write abstracts is by reading actual abstracts. This is a good one. It's a little ancient, 1971. Okay, so I'm just, do I get, I want, uh, stamp, spotlight, okay. How subjects decide that the string of letters is a word, right? Oh, there we go. So I can actually use, ah, go away. Here we go. That's what I want. Okay. Subjects decide that a string of letters is a word. So they start from the very beginning, and now they say, here is the definition of a lexical decision as a function of the string's meaning, similarity, etc. Also, I encourage you when you read such articles to pay attention to the square paragraph rule. What is the transition here? What is the key sentence here? What is the evidence? Okay. So in this first paragraph, they talk about previous research that led them, that is Meyer and Schwaneveld, to this current research. And as you notice, Meyer is one of the persons who did a lot of that before he paired up with Schwaneveld, right? Okay, so here is the very beginning of this paradigm. Look, it's 1970, which is just a year before this article. Meyer and Ellis, okay, they tell us about what they did. So this is about category size and so on, right? Now this is the explanation. Suggested that semantic decision may have been involved searching through stored words in the semantic category. So they're telling us why they did that. So these are the first two paragraphs that they bring up to the point what they are going to do. Why are they doing that? They're saying they will provide further data about the effect of meaning on lexical decisions. Okay. Why is it new? They say, well, we have extended the lexical decision task by simultaneously presenting two strings of letters to subjects to judge. So in the first two experiments, whatever these people did, they always would give people one word, one string, right? So there is nothing to prime. Oh, well, something is probably priming, but you can't control it because you're only giving subjects, your participants, one string. So this is the novelty. That's where the priming comes in for Meyer and Schwaneveld. They say, instead of giving our participants one string, we're going to give them two. And we will use that as our deep independent variable that will have two levels, right? And like I said, I told you to ignore anything that has to do with non-words because we just don't need that. So what is the manipulation? If you're presenting two words, you are creating a potential situation where one can prime the other, right? So they're describing the two tasks. Second task is of no interest to us because that's experiment two, right? Let's go to the next page. Remember your third paragraph of the introduction where you say, what is it that we are trying to test? What is the research hypothesis of our study? And here they say the two tasks together designed to give information about the nature and the invariance of underlying retrieval operations. When they say retrieval operations, that's how you retrieve the word from your mental lexicon. When you retrieve the word, you recognize it as a word. When I gave you a clip, there's nothing for you to retrieve because there is not a word like this. But for clout, you had to kind of search through your mental lexicon. And now they're telling us in the very last sentence of the introduction that experiment one, right, reports the results of such variation in the context of yes-no task because experiment two is a different task, same, different. Okay. Now what we want to look at is the design. So this is, remember, this is 1971, so APA style was quite different in those days. They have procedure and design together. You have design and materials and procedures separate. Okay. And that's one of the things that you need to pay attention to because you often confuse or repeat the same stuff in design and materials and then procedure. Procedure is just physical steps. Design, variables, task examples. Okay. And this is where what they call stimuli would be design and materials for us. So this is how they explain that. They had 48 pairs of associated words. We will call them related. And in our case, they were not, it wasn't 48, it was 30. So write it down. You had 30 pairs of related words. In fact, you will recognize them, right? You had bread and butter, and you had nurse and doctor. They selected them from the association norms. I selected them from their article. And then they had 48 unassociated words, and we will call them unrelated words. And look, all you have to do is take the first string from here and take the second string from here, and you're going to get an unrelated pair: bread, doctor, or butter, nurse, right? Okay. And we don't care about the rest of the stuff. And here is what they talk about. Non-words, we don't care. Only related and unrelated words, or associate, unassociated, the way they call them. Okay, within each pair, the second member, also 30. So you had 30 and 30. Plus you had 60 fillers. That is, fillers are those stimuli where you get a non-word. Because if I were to give you 60 trials where you always say it's a word, you'll say, well, what's the point of the experiment? You needed to sort of think. That's why I needed to create as many distractor or filler trials as the experimental ones. So you had 120 for the whole experiment. They also talk about how related they were. We don't care. Median length, we don't care about any of that. They really want to make sure that this is all matched. I tried to match more or less. And then they describe the non-word conditions. Again, nothing that we are interested in. So note that there are examples. So many of you don't remember put the examples in design and materials. That's what you should absolutely correct. They have apparatus. We don't. We only have procedure because our apparatus is online platform finding 5. That's it. Okay, let's go to the results. That's what we need. So I took out the remaining 3 conditions out of this table so that you don't get confused. Also, remember, you need to sort of dissociate yourself from participants. Yes, you are the participants and the experimenters simultaneously. That's an unusual situation. So I think one group constantly wrote about themselves as us, the participants. Ignore that. Think of these people as if it were not you, but somebody else. Your role is the role of the experimenter. So when you say we, you mean the experimenters. You don't mean we, the participants. You understand that? You need to be. Yes, sure, of course, Ari. Yeah, absolutely. Okay, so remember I said we're going to call this related and unrelated, but that's the same, right? We don't care about, let me finish that. Let me do the annotation now. We don't care about correct responses. In fact, in your these 2 conditions, in the 60 trials that you had, there were only 5 errors, which means you guys did very well in lexical decision task. You performed it correctly. We don't care about the proportion of trials. In your case, it's going to be 50-50, right? And we don't care about errors. So all we need for our paragraph 2 of these numbers. Please write it down. These numbers have to be included in your paragraph 2 of the introduction. You actually have to say. And they found that lexical decision task was significantly faster for pairs of related words, 855, compared to pairs of unrelated words. So now use our terms, which was 940. So what's the difference here? 85 milliseconds. You need that because you need to compare these numbers with your numbers in the discussion section. When you say, let's look at our data and data from Meyer and Schraneveld, they found 85% priming effect. So this is the priming effect. The word that is related primes the one that is related to. When the unrelated, there is no priming. Okay? So we call it the magnitude of the effect. Was your magnitude of the effect the same or different from theirs? Good. Close that. And so they're saying there were 5 types of stimuli. In your case, there were 2 because you only have one independent variable with 2 levels. Okay, this is level 1, related words, and this is level 2, unrelated words. And you should use the words independent variable and levels and examples and numbers, right? Results in discussion. Because remember, in those days, uh, the APA was different from what we're doing now. So here, the, it's not the issue, but you need to understand that because they had more than one independent variable, they conducted a different test called ANOVA. And each test has its own letter. The test that you are guys doing is a paired samples t-test. So in your case, it's going to be a lowercase t, followed by only one number in degrees of freedom, which is the total sample size minus 1. So in our case, we have 18 people who contributed data because one person did not do the experiment, minus 1. So your degrees of freedom is going to be 17. And that's how you will write it. You will write T 17 in parentheses equals to whatever that obtained T is going to be. You can either get it in JASP, you can do it in Excel, you can do it in SPSS, and whichever way you want to do it. Followed by this P value. In this case, this is error rates. The P was larger than 0.1, means there was no difference. Okay. And here is, let's look at the reaction time data. That's what we want. Okay. So they say table 1. This is table 1, right? You don't need a table because you only have 2 numbers. They will be in the text. All right. So look how they describe the magnitude of the effect. The effect is the priming within the pairs of strings that are related, well, pairs of words. They say yes responses, which means it's a word of English, averaged 85 milliseconds standard deviation, faster for pairs of related words than for pairs of unrelated words. And again, remember, they are doing ANOVA, you are doing t-test. So F17, whatever this number, oh, and look at a huge p-value. P-value is less than 0.001. Huge, I mean small. The smaller the p, the better. The p needs to be smaller than 0.05. And we don't care about the rest because no responses are non-words, and we don't even analyze them. Okay, and then you will continue analyzing the article. See, I didn't delete this empty page. This page and the next one are the general discussion. And here is your spreading excitation model that I just discussed a minute ago. This is a little technical, but not too bad. Okay, let's stop doing that and move on to Excel. Well, let's go back to our stuff. So that's Meyer and Schraneveld. And remember, we are measuring reaction time, priming. We're not measuring accuracy. Like I said, there were only 5 errors in 60 items times 18. A lot, right? Very good performance. And we're talking about semantic priming, the benefit. That is the speed up of retrieving of the second word when it's primed by the word that it's related to. So retrieving doctor primed by nurse. Okay. And you don't get that when you retrieve doctor because there is no priming from butter. And that would be one kind of a representation of a mental lexicon. So you could think of that. So here is your nodes, right? Red, green. So yes, reaction time not is only our main focus, it's our only focus. There is nothing else. So that would be a very schematic representation of some connections in the mental lexicon. So this study is about mental lexicon. So it's about language and categories, both. Good. All right, so now we're ready to look at the bar graph. So let's stop that and go to Excel. Ask me questions if you have any. Let's make it larger. Okay, these are your data for experiment 3. All right. Remember the column A participant number is just there for your information. You don't do anything with it. I could have deleted it. It would not have affected our results. It's the numbers that finding 5 assigned to you. I don't know who these, I mean, I do know if I look at the original FF data because I asked you to provide your name because you're supposed to contribute data. But now I have no idea who's who. Now, if you look at this data, right, we have somebody whose number is 373, who is a Speedy Gonzalez. This person just, maybe it's a video gamer. Hey, we don't know. But note, if you just compare one by one, right, you see this person gave us 500 millisecond reaction time, extremely fast for related words, and a little bit slower by 39 milliseconds for unrelated words. Then you can see that most other people are sort of between around 1500, right? So here's a bunch of people here. Most of them are the same. They're faster in related, they're slower in unrelated. But here is the opposite pattern, right? So subject participant number 409 gave us 1296 in the related condition and 1257 faster in the unrelated condition. This is 17 millisecond difference. This is a bit more. This is significantly more, right? This is the opposite pattern again. This is 10 milliseconds faster in slower in the related condition than an unrelated condition. And then we get a bunch of people who are slightly slower. All right, so these guys. Here is a 300 millisecond difference, huge, right? Here is a 400 millisecond difference. Again, for related words being faster than unrelated, right? This is the same. This person gave us the same reaction time. Here is an opposite, somebody who is faster. And then there is somebody who was a little slower than anybody else. because it's almost a whole second difference here. But in general, this person's reaction time is quite slow. Okay, so what many of you did, not everybody, many of you did when I asked you to create a bar graph, you said, okay, let's select all of this. These are the two conditions. Remember, we don't care about participant number. And we're going to go into insert and choose columns because that's what I asked you to do. Take this. Whoa, you say. Okay. What do you see here, guys? Colors. Okay. Well, that's going to be an APA issue. We can fix that. For now, we'll keep them so we can discuss. If I, Amanda, not just you, but everybody else, if I were to ask you to give me a quick uh, explanation of what you see, number 17 has a big problem with unrelated words. Okay. Unrelated is taller. Yeah. But Leroy, let's look at number 3, number 7, number 9, almost number 10, number 14, number 16. The difference is very minimal, but remember when you look at numbers, algebra and statistics are different things. Numerically, they may be different. Statistically, it may be the same, and the other way around. But what is the problem with this, looking at this figure the way I presented it to you right now? On average, Leroy, explain what you mean.
Like if you take all the times on average, everything done related would take longer.
Mm-hmm. Thank you, Leroy. So the problem presenting your figure like this is, let's see if I can explain it in the way that you understand. Here's an easy way of doing that. So this is a very small experiment, right? We have 18 people. But imagine, which is very easy with online platforms, that I were to run an experiment where I want to get 1,000 participants. That's not unheard of. We do that. Can you imagine my figure with 1,000 participants? What will you do if somebody presents you, even technical, if it were possible, which is hard? I wouldn't, yes, you would not look at that, right? And the problem is you don't want to look at individual people. You don't care really, unless you're doing special experiment on individual differences. So for example, one could say, hey, we need to, there's something special about participant 673 because that person is probably a couple of standard deviations from everybody else. And we would normally, this would be called an outlier, and we would delete that. But in general, what we don't see when we look at individual data, we don't see the patterns. We don't see the effect. Remember, the effect is the difference in dependent variable between level 1 of independent variable and level 2 of independent variable. If you want, Leroy, I can check, but it doesn't matter. That's not the point. The point is that we don't want to look at individual differences. We want to look at the pattern, and the pattern is our research hypothesis. Are related words processed faster because one of them is primed by the other? And that's the priming effect. And the only way to see that, especially if we were to have 1,000 participants, is to ignore the individual differences and go to averages, just like Leroy said. So I'm going to delete this, and I would like you never, ever to use individual data because it's meaningless. It's not telling us anything. Yeah, some people are faster, some people are really slow, other people are the same. We don't care about that. We want to know, do you retrieve related word faster than unrelated one? So by what we're going to do, we are going to, yes, Brandon, yes, fantastic. We want to take the averages, and to do it in Excel, you'll start with the sign equal mark, right? Type the word average, open your parentheses, and then select all the data, close parentheses, hit enter. Now, because these are milliseconds, we actually don't need any decimals. So I'm going to get rid of them. So mean, right, for unrelated words is 1705. And this is regardless of whether you're fast, Speedy Gonzalez, like 373, or the person who was slow, like 673. I can do the same here. I'm lazy, so I'm just going to copy that and paste it. So now, what is the magnitude of my effect? Well, you say it's a formula. Take equal sign, take the unrelated time and subtract the related time, right? So this is the magnitude of the effect for you. What was the magnitude of the effect for Maya and Schwaneveld? Who remembers that? $85. Thank you, Rebecca. Exactly. $85. So now, imagine you're writing your discussion section, your paragraph 2, where you have to compare similarities and differences. So what's similarity number 1? Between Maya and Schwaneveld and our data? Millisecond. Yes, good, Rebecca. So did Maya and Schwaneveld find priming? Yes, right? Related words were faster. Did we find the same effect? Yes, good. Thank you, Rebecca. So similarity is priming is present in both of our studies. Yay, excellent. Now let's look at the differences. Oops, shouldn't be here. Maybe more than one. So let's say difference. So what's the difference that jumps at you when you're comparing these two numbers? Oh, numbers are higher, right? In general, if you look at Maya and Schwaneveld, that was what, 855 versus 9, no, 940 or something like that, right? So that's Maya and Schwaneveld. Oops, you say. Interestingly, you guys, if we were to conduct a statistical analysis, you would have been statistically significantly slower than people in 1969. Oh, 1971. So that's difference number 1, right? You are slower. We are slower. Okay. In general, that is, regardless of whether it is related or unrelated pairs. That's what's difference number 2. And it's not just a question to Rebecca, who is doing very well. Somebody else. Participant numbers. Yeah, they had 12. You guys had 18. So in fact, you have more participants than they did. But that's irrelevant. Number of participants, especially at this level, is not something that you even need to um, talk about. Look at the magnitude of the effect. Mayan Schwaneveld, different differences. Yes, good. 85. Your difference is 151, almost twice as much. So your magnitude is twice. So these are the three things that you have to have in paragraph 2. And for anything that's different, so these two things, you need an explanation. That is, you have to hypothesize. Why is it that you're in general slower? But simultaneously, the difference between related and unrelated words in priming is twice as much for you than it was for Maya and Schwaneveld. And here is you can, use your knowledge of cognitive psychology. Just don't say anything about the number of participants because they had 12 and they were all high school kids. I don't think there were video games in 1971. Okay, so now we're ready to tackle this information is for the second paragraph of the discussion. I need one more thing that I don't have that you will need for your text, which is standard deviation. And Excel, I'm going to get rid of actually move them away so that I can play. So Excel does it for you as well. STDEV, that's standard deviation, open parentheses, do not include the mean, of course. Right, let's get the standard deviation. All right. Yes, it will be. It's recording. I just have to do it tomorrow probably. Copy. So here is one interesting thing, right, that you will notice immediately, that the standard deviation for the related condition is 200 milliseconds smaller than in the unrelated condition. That means that you guys are more homogeneous when you process related pairs, when you process unrelated pairs. Why? I don't know. But here's what we need now. We need these four numbers. So I'm going to note that they are formulas. This is where you see it. That's a formula. I don't need formulas. Go away. Kill that, but I'll copy it from here. Okay. So I'm going to put it here and I will say, here's my mean, RT, right? Here's my standard deviation, but I don't actually need it in the table. So let's not even put it here. We have related, if I can type it correctly, related and unrelated. Maybe we will say related pairs. Unrelated pairs, right? And the numbers are 1705 and 1809. So now note that I'm not looking at individual differences anymore. I'm looking at the entire sample. And all I want to know if there is a difference between the two conditions on average. So I'm going to go back into my, okay, right, there it is. It does not look like APA formatted figure. First, no title in the figure, no grid lines, no color. This is a little crowded, so I'm gonna, the only problem is I can't get to that. Okay, let's see. Format. Okay. Format shape. Now close. I need form. No, but my zoom controller over that. I can't get to this. Oh, okay, maybe I can do it this way. Can you guys still see my screen? Have I lost you? Okay, good.
Okay.
All right, so good. Let's go to, all right, I want to select this and I want to format selection and I want to, let's say I'm gonna make it fixed. Major unit, let's make it 400. Sorry. Oops, no, that wasn't good. Too much. So let's do 100. Okay, good. All of that is still not quite APA, so you can quickly fix that by saying it cannot be Calibri, it should be times Roman, and it should be 12. You can make it bold, it's allowed. The same here, it's going to be times New Roman, 12, bold. And what we don't want is, we don't want this border around that. That's not APA. So format, selection, and say border color, no line, close. Okay, so now I have my beautiful figure. I'm gonna copy it and post it, not post it, paste it in my Word document. So let's do that. So I'm gonna close this and open Word. Give me a second. Uh, Technically, you could, Amanda. The problem is whether you will be able to create a figure that's APA formatted. If you can, that doesn't really matter because we create figures in many other programs. So let's do this. Now let me share it. So if you can create it in Photoshop and it looks like APA, then you're fine. It's usually not so easy. All right, there it is. Let's make it bigger. So here we are. We want to start with the word results. Of course, it has to be times Roman and should be 12. So I'm checking all of these things, which are my, and it has to be bold. Now we don't want it to be bold. And now first paragraph, right, is the descriptive statistics. And we start with repeating the task. The participants performed da 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 da. Then we have to describe mean RT. In parentheses, standard deviation. Okay. So remember that these statistical terms are all in italics. That's the requirement. And I'll show you how it needs to be written in normal human language. So don't put any standard deviations in the figure. You cannot have 2 more bars for standard deviations. That's wrong. Standard deviations show us the fluctuation of the scores between the means. People who are above the mean, people who are below the mean. So they're usually represented as error bars, but I'm not teaching you how to do that because it is a little, I mean, I can do that, but it just takes time. Note that I haven't done one other thing which you should do. I have not created the axis titles. So this axis title will be reaction time, and this axis title will be, I don't know, type of pairs or something like that. So this is what I refer to as descriptive stats. And you actually repeat the hypothesis and predictions that come from the last paragraph of the intro. All right. And then you start with describing, repeating what the task was and giving us means and standard deviation. Right here, oops, why did I do that? Is going to be my inferential statistics paragraph. Okay, of course, should be Times Roman again. I should change that. So now our figure needs one. So our figure needs the axis titles, which I haven't done, and it also needs a caption. The caption is as follows: Figure 1. Again, Times Roman. Sorry for wasting time on that, but what can we do? It's bold. Okay. Then comes the actual caption, that is the title. And the title should be the dependent variable as a function of the independent variable units. And units in our case, because that's reaction time, milliseconds. And that is in italics. So once you add the axis titles, voila, you have the APA formatted figure. And that's what it should look like in your lab report. So finally, inferential statistics. Well, let's look at the, so remember our inferential statistics is paired samples, samples t-test. I don't have time to do it, but I'll show you what it should look like. All right. So you will start by saying, we analyzed the data, the reaction time data, with a paired sample t-test, blah. Okay, so stop that. Go back to, yeah, okay, good. Go back to the narrative. Okay, so here is an example from the APA publication manual about how to write descriptive statistics. All right, so here they say, first is an example of how, oops, let's go back, of how mean and standard deviation information can be presented in the text. That's how you should do that. So look how they did it. They say overall men, which is level 1 of the independent variable, did something harder, in your case faster, right? That's your dependent variable. Then level 2 of your independent variable. In our case is level 1 is related words. They were faster than unrelated words, right? And here is the mean, followed by the actual number. In this case, they put standard deviation just following by with a comma. That's fine too. So they're giving us two means, one for level 1, right? One for level 2, and two standard deviations. Okay, they're also giving us the actual statistics here, which I don't want you to do. I want you to do the statistics, inferential statistics, in a separate paragraph. Okay, so that might be a little small paragraph, but it's all right. Next, clear that. Go to inferential statistics. Inferential statistics, remember, tells us whether the results obtained with a sample will hold when they're extended to the entire population. I don't have time to go into a lot of statistical issues for you, but I told you which test to do. And here's how you would write that. Now, they here, this is again an example from the APA publication manual. Okay. They have some gobbledygook here. 1 degree of freedom contrast, blah. We don't need any of that. We will repeat again the sentence that related words pairs were processed or retrieved faster. In fact, you were not retrieving the whole pair, you were retrieving the pair in cap letters. Make sure that this, how did you know which word to react to? Well, because you were told to do a lexical decision task on caps. But here is what you need to learn how to do. Only these two things. Don't do Cohen's D and don't do confidence intervals. I didn't teach you any of that. And not many people in stats teach you that. So here is, we start with T, lowercase, in italics, followed by degrees of freedom, in our case 17, because there were only 18 people who completed the data collection. Whatever this number is, okay, followed by, I already did the stats. I know it's going to be significant. Okay. Oops. Let me change that. And now, okay. Yes, absolutely, Denise. Our dependent variable is reaction time.
We don't see what you're typing.
It should be in chat.
Oh, sorry, I didn't see that.
Yeah. I'll look, Leroy, I'm switching between different screens, and that's one of the issues. Okay. Let me see. Do I have anything else to show you? Right. Good. Okay. So at this point, we don't have a lot of time, but still, we didn't take a break. Sorry, guys, but we have about 15 minutes. So what I propose, let me stop sharing this, is that you go to Excel or Google Sheets or whatever else you have access to. If you don't have access to any of those programs right now, do it in your notebook. And in the remaining 15 minutes, create a figure, okay, using the data that you can download from Blackboard right now. And if you know how to do a t-test, which I didn't show you, show me the actual results of the t-test. And I'm here with you until 12:05. So we have actual 17 minutes. Of course, you should do it together with your group members. So maybe what I will do, I'll send you to breakout rooms with your uh, so what we have, 11 people, right? Breakout rooms. Well, let's create 11 manually. Okay, you have to remind me. So group 1 is Karen and Raphael, right? Yes, Karen
Yes.
and Raphael. So I'm going to open the rooms now. Go to the breakout room with your partner and start doing it together. Open the rooms. Okay. Who is group 2, guys? Group, Group 2 is Julia and Denise. Okay, Julia, sign to group 2, and Denise. Where's Denise? All right. Amanda, which group are you in? With who? Nisreen. Okay. And you are group 3. Okay, good. Sign to group 3. And Nisreen, group 3. Okay. Amr, which group are you in and with who? With Parker. 11. Okay. Parker. 11. Brandon, which group are you in and what is the number of the group?
I'm 6, and it was switched from Bishoy to Diamond. Group 6.
Okay, good.
I mean
Group
Diamond.
6. Yeah, Diamond. Okay, good. And Diamond group 6. Isaac, you are with Justin and Nick in group 10, right? 10. Julia is group 2. Okay. Justin, group 10. And Nick, group 10. Jeffrey, which group are you in and with who? Rebecca, group 4. Okay, I see. Group 4. Thank you, Rebecca, group 4. Uh, Leroy, you are with Ari, right?
Yeah, but he left.
Yeah, he left because he's not feeling well. Okay, so I don't need to send you to a group. Just work on your own, right? Melissa and Noor, you guys are which group? Group 8. Good. All right, group 8. Melissa and Noor. So Melissa and Noor, join. Go to group 8, to room 8.